Now, in summary, standing wave arrives from a superposition of identical waves traveling in opposite directions. It's a resonance phenomena that only happens at certain frequencies. But what we find is that for the case with the string that's clamped at both ends, if F1 resonates, then F2, which is twice F1, will resonate, and F3, which is 3 times F1, will resonate, and F4, which is 4 times F1, will resonate. We call this the first harmonic, the second harmonic, the third harmonic, and so forth. So the 17th harmonic would be 17 times the first harmonic. It's that simple. Now, nodes are points where there is no oscillation. Even though the whole thing's going crazy, those points don't move. The antinodes are where the movement is the greatest. They are spaced equally, centered between two nodes. Now, the name of the game with these standing waves is to find these frequencies. And here's the thing you need to understand. I can't draw frequencies on a blackboard or a whiteboard. You can't see frequencies. But I can draw wavelengths. I can draw pictures of wavelengths. And once I find the wavelength, I can find the frequency. And it turns out that not only is this equation valid for standing waves, it's valid for every harmonic of the standing wave. So this is valid for the first harmonic, this is valid for the second harmonic, this is valid for the third harmonic, and so forth. Okay? So let's see if we can find those wavelengths. And once we have the wavelengths, we can use that formula to find the frequency. Okay? Well, this is the first harmonic. I only have one football. Okay? It's the lowest frequency, the longest wavelength that will fit the boundary conditions. The boundary conditions are, I got to have a node at this end, I got to have a node at that end. So the longest wave that will fit is one football. Now, folks, if I look at a wave looks like that. It's got an up and a down. So for a standing wave, when these things are going back and forth, if I wait half a period, this thing's going to look like that. And that's one wavelength. Or now, folks, nowhere else on the planet do they call those footballs. I'm the only guy. So if you go somewhere else, please either don't use that terminology or don't tell people that you learned it from me. But I think it's useful. I think it's a good way to learn because you can visualize those footballs. Now here I've only got one football. It takes 2 footballs to make a wavelength. I've only got half a wavelength. Okay, there's the nodes at the end. There's the antinode in the middle. And I only have half a wavelength. Now what I want to do is I want to get that wavelength in terms of the length of the string. And the length of the string is capital L. So if L is half a wavelength, that means the wavelength is 2L. Okay, so let's go over here to the wave equation and find out what the first frequency would be. Well, V is equal to the frequency of the first harmonic times the wavelength of the first harmonic, which is 2L. If I solve that for the first harmonic frequency, I get V over 2L. What's that? Who's that? Charlie. Okay, remember I told you would see that a lot?
Is that an acceptable answer, I'm
No. If you put Charlie and talk about Charlie anywhere else, I'll deny it. I'll say that I never taught you that, and who are they going to believe? All of you or me? Yeah. Okay. Now, if we go to the second harmonic, now I've got 3 notes. More importantly, I've got 2 footballs. I've doubled the number of footballs that fit on that string. If I double the number of footballs that fit in the string, the footballs have to be half as big. Well, if it takes 2 footballs to make a wavelength, that means the wavelength just got half as big. Okay? In this case, it's easy because I got the 2 footballs there. That means the wavelength is the length of the string, L. But here's the important part. That's half what it used to be. It used to be 2L, and now it's just L. Now, if we go to the third harmonic, now I've got 3 footballs. What is the wavelength in terms of L here?
1/2 L.
Is it half L?
2/3.
2/3 L. Now, some of you could just visualize that. You say, well, 2 footballs is a wavelength, and that's 2/3 of the total L. Let me show you another way if that doesn't work for you. This formula will be on the front page of the exam, except if you tell anyone, I'll deny it. It's the number of footballs times lambda over 2 is equal to the length of the system. Now, if I did that for this problem here, I would say I've got 3 footballs times lambda over 2, and that's going to equal the length of the system. If I solve that for lambda, I get 2/3 L. Did I get that right? More importantly, that's 2L over 3. What's 2L? 2L was the first wavelength. And so what we've seen here is that the wavelength goes from 2L to half that much to 1/3 that much. Anyone want to guess what the next one's going to be? 1/4 that much. Okay? Now, if I use the wave equation, if the wavelengths are getting smaller by a factor of 2 and 3 and 4, and the speed stays the same, then by that wave equation, that means the frequency has to get bigger by a factor of 2, and then 3, and then 4. Okay? And those are the harmonics. Okay. A consequence of that wave equation. Now, folks, I have to pause here just to kind of explain some name calling. These waves are owned by the physics department. But the music department thinks they own them too, because this is music. In the physics department, we call this the first harmonic, the second harmonic, the third harmonic, because we want to use that mathematics. We want the third harmonic to be 3 times the first harmonic. Over in the music department, they don't care so much about the equations. They just want it to sound pretty. So they call it the fundamental, the first overtone, and the second overtone, so forth. Now, have any of you lived in Germany? Or been to Germany? If you go to visit a friend and they live, well, you have to go up 1 flight of stairs to get to them. Which floor do they live on? The first floor. Okay, the erste Geschoss. If they live on the ground floor, they call that the Erdgeschoss, the ground floor. Okay? And so they go from ground 1, 2, 3. And so if you live in the penthouse on the 5th floor, there are 6 stories in that building. It's not that one way is right and one way is wrong. It's just that the physics department is right. Now, it turns out that we have adopted the language of the music department on the fundamental. Often we will call that the fundamental instead of the first harmonic. We'll use those 2 interchangeably. But we will never call that the first overtone, because that will mess up our mathematics.